Hello class, here's the dynamic binding demo program that I messed up on last night. I didn't notice that there were inner classes, which is what fouled me up. So what I've done here is I've commented them out and I've made separate files over here in the package for each of the classes. I just copy pasted them. Here's the first one, person, which extends object, has a toString that's going to return person. Here's the student class, which extends person, and it will toString will return student. Here's the graduate student, which extends student. Now, you might wonder, well, why did I do that? Well, I did that specifically because I wanted to be able to make this UML diagram. Since I have files over here in the package, I could then create the object-aid UML diagram. So here's the superclass of the set, person, at the top of the hierarchy, and it extends student, and then student extends graduate student. No big deal, but I just wanted you to see that. Now, I also changed the rectangle class a little bit. What I wanted to do, I wanted to demonstrate the equals method. When you make your own custom class, and if you want to compare two objects of that class to see if they're equal, you have to define your equals method in that class. You get to decide what makes equality in that class. Well, I've decided in the case of a rectangle that rectangles will be equal if their area is the same. And so I've set up this conditional expression here, as you can see, to return true if the areas are the same and false if they are not. Remember that this conditional operator is a substitute for if and else blocks, right? But a nice short form in this case. Okay, more about that later. We'll see how this works later. Now, I also mentioned briefly last night that we could make a triangle class, and so I thought, what the heck, let's make one. So in a triangle, we've got three sides. I'm going to call them A, B, and C. So those are our attributes. We've got our constructor here. And I wanted to use a verify method to verify that you could, in fact, make a triangle with the three sides. Because as you might know, you cannot make a triangle if one of the sides is longer than the sum of the other two. That's the rule. So what I did was I made an array with the three sides, with the three attributes, called sides. And then I sorted that. And my reason for sorted that was to determine where the longest side was. Well, after sorting, that's going to be the one with index 2. And so here's the Boolean expression here. If index 2 is greater than the sum of the others, then we cannot make a triangle. We cannot verify. Otherwise, we can make a triangle. We return true. Okay, I also added an area method. No point in finding the area if you can't verify that you do in fact have a triangle. And so I used if this verify here. And then I used Heron's formula for finding the area of a triangle. It's a better formula than 1/2 base times height, which you might have learned. The Heron's formula allows you to find the area if you know what the lengths of the three sides are. And that's what we have here. And then I got a little bit carried away. I said, well, what the heck? Let's see if we can determine what the angles are. And in order to do that, you would have to use the law of cosines. So I used the law of cosines to calculate the size of the angles. Now, I'm not going to worry about that. You certainly don't need to know that for this course, but I thought you might find it interesting to know some of you are into math. And then, instead of having a toString method, I wrote a print triangle method here, which would basically operate like a toString method. Okay, but once again, I used verify to make sure that we could do it. Okay, now, by doing that, I added another shape. So now I modified, I was able to put the triangle class in the UML diagram. So here's the UML for all of the classes now. Okay, now we'll also change the name of the executable file that uses these objects. I believe it was called test circle and test circle rectangle. Well, I've changed it to be test geometric objects since I added a triangle. So it starts off with the same code. Got the same code here as I think the author gave us, with possible exception that I think I changed this here. I think they changed the dimensions of the rectangle to 2 and 6. And I wanted to do that because I wanted to see if my equals method worked. So I made another rectangle down here called rec with dimensions of 3 and 4. Obviously, as you can see, 3 times 4 is going to be the same as 2 times 6. So these two rectangles should compare as equal. That's what we should get out of this. There's our equals method. So I just wanted to test that equals method. Now I wanted to make a few triangles, so I decided to make an equilateral triangle with all sides 5, an isosceles triangle with 2 sides 5, and then another triangle in which one of the sides is longer than the sum of the other two. And you can see that's the case here. 5 plus 4 is 9, which is less than 11. So we can't make a triangle with those sides. I wanted to make an array with these triangles. So I used the array initializer syntax with the curly braces and called it try. And then I wanted to loop through that array using a for each loop, which is what we've got here. So let's see how this runs. Okay, the first part of it, there's no real change. Here's the part where I changed it. You can see there's the result of running the equals method, and of course with the area of 12 we did get true. Here's the equilateral triangle. You can see all the sides are equal, and as you might remember from your mathematics, an equilateral triangle, all the angles are also equal, and they're all equal to 60. Here's the isosceles triangle, and 2 sides equal, and as you also might know, 2 angles are equal in an isosceles triangle. So it looks like the angles method is working properly and getting the right results. Area of that one would be 12. And here's the verify is not allowing us to make this triangle. So I wanted you to see that. Hope that helps.